Ready for class test. Photos of class not a class. So today we will discuss shall we get started? Okay. No. Okay. So you know the name of this chapter, right? So what is it? It's called ray optics and optical instruments, right? So the ray optics part is over, right? We saw how the light will get refracted when it is passed through different kinds of optical substances. Here, the last part that we're going to discuss is optical instruments. Okay. So those who are online, are you able to hear me?
Sir, your voice is low, sir.
Voice is lower. Is it better now?
Yes, sir.
So we will discuss about optical instruments. So what are optical instruments? So why do we use them? Let us say there are certain objects that we are not able to see with the naked eye, means without the help of magnification, right? So there are certain things which you can't observe. For example, you would have used it in your lab also. Let's say you want to measure the length of this pen. Okay, you want to measure the length of this pen, you're going to take a scale and keep it like this and try to coincide with the numbers that are present on the scale. Will you do that or? Yes. When you do that, suppose you want a more precise reading, right? When you want to have a more precise reading, instead of you going closer, what is the other technique that we can use? You can use a magnifying glass in between. Magnifying glass is also called as it's a simple microscope. So magnifying glass is also called as a simple microscope. Why do we actually use it? Just to avoid the error. In a similar way, you have these microorganisms which you can't again see with the naked eye, right? So for that, what do we use? We use another type of microscope, which is generally present in the biology lab. We call it as a compound microscope. So name is suggesting both are microscopes only. Here you call it as a simple microscope because you have only one lens present. The other one is called as a compound microscope because you have two lenses present in it. Because it uses the concept of when two lenses are combined together, the magnification gets multiplied. Okay, so this is the outline. And the third type of optical instrument that we'll be discussing is a telescope. So where do we use telescope? Generally to look at the astronomical objects, right? So to look at the objects which are at a greater distance. Do we do this or not? Right? So shall we move on? First, you concentrate here. So what are we going to see? First is a simple microscope. So what is a simple microscope? Before that, I just want to conclude that optical instruments are those devices which are mainly used for magnifying things with the help of refraction. With the help of the concept of refraction, or you can use reflection also. Mostly we go with the concept of refraction. Okay. So first, what is called as a simple microscope? So what is a simple microscope? So simple microscope is also known as a magnifying glass. But what is it? It is just a simple convex lens of what kind of focal length? Do we need to have less focal length or greater focal length? Depends on by this. By this. Is it because it is given here? Do we need to have a convex lens? Why do we need to have convex lens in the first place? Why can't we use concave? Concave lens always forms a virtual image, no doubt in that, but it always forms a diminished. So there is only one optical instrument which can generate a magnified and virtual image. What is it? It is a convex lens. Where do you need to place the object for that? You need to place it between the optical center and the focus. But here the question is, why do we need a convex lens of short focal length? Why can't we use a large focus? Oh, we don't know. What is the formula for magnification? One by V minus one by U is one by F. That is the lens formula. That is not magnification. Magnification is V by U. But V by U has nothing to do with focal length. And how do we know that this lens is supposed to have a short focal length? So that obviously we'll be able to see only if we derive the magnification for this particular scenario. Is that right? Shall we proceed with that? Right? Suppose. So here I want you to make a note of two things. One is solution. Suppose I want to see this pen. Okay. I want to see this pen in this. What am I trying to say? I want to see the top and bottom of this pen. Okay. I am not using, so suppose I remove my specs. Okay. I have some side. Okay, accepted. If I see this, then I need to keep it at a certain distance. Right? I need to keep it at a certain distance. So if I bring it close, do you think I can see it completely? You guys try and see. Will you be able to see it completely? You can't, right? So you'll feel some strain also. Similarly, you'll try to take it far away. There will be one particular moment for the first time where you will start feeling the comfort. So when I say comfort, at that point you are able to see the top as well as the bottom without any strain in your eyes. Is that right? So that distance, if I keep it like this, if I keep this bottom exactly parallel to my eyes, so if I keep it like this, okay, visualize it. If I keep it in this way, my eye is making an angle with respect to the top. Is it right? So is it in this way? So I'm just trying to frame a right. I could have kept it like this also, so that top also I'll have some angle, bottom also I'll have some angle, but I didn't do that. I kept this exactly along the line in the side, in the line of my vision. When I keep it like this, my only headache is about the topmost point. So when I look at it, I am able to frame a right angle triangle. I am able to form a right angle triangle so that it makes an angle alpha. Is that right? Is it right? Okay. So when this happens, you are able to see it a certain distance, right? This distance is called as the least distance of distinction. What is it called as? Least distance of distinction. Or it is also called as near point. It is also called as near point. What do I mean by this? It is the nearest point where your eye is able to see the object without the strain for the first step. What is going to be the far point? Far point for any eye is infinity. Near point is generally it is the person without a sight is 25 centimeter. Okay, for a normal eye it is generally 25 centimeter. So which is written as capital T. So what do you call capital T as? What did I tell the name is? Near point is already known to you, no doubt with that. But what is the other name I told you? It's called the distance of distinct vision. LDD. Okay. Now, first, when I'm looking at the object without the help of an optical instrument, I am able to see an angle, right? That angle, I'll call it as alpha. Means if I draw it as a diagram, this will be alpha, and let the height of the object be h naught, then how much will this distance be? Will it not be capital D? Are you guys able to understand this point? Right, it is going to be capital D. Now what you're doing is you're going to look at the same object of height h naught, but what you're doing is between your eyes and the object you're bringing in an optical instrument, that is a convex lens, in such a way that the position of this object is adjusted so that the object distance is going to be somewhere between the focal point and the optical center. Okay, when that kind of a scenario is achieved, observe the ray diagram. If I consider one of the rays parallel to the principal axis, what is going to happen? It will pass through the focus on the other side. Whereas if I take one of the rays through the optical center, how is it going to pass? It is going to travel without any deviation. Am I right? So that you have a virtual image formed. So this is where the object is placed. AB is where the object is placed, and the virtual image is formed at slightly greater distance. So since it is formed at a slightly greater distance, only it is magnified also. Are you able to understand? And are you in acceptance with the fact that this is a virtual image? Hey. Okay. So are you able to understand what I'm trying to say? So here there are certain things that we combine in the same diagram. So observe it clearly. So when I take it to this point, right, I am able to see some angle here. Right? You're able to see an angle here. That angle, if I call it as beta, what am I calling it as? I'm calling it as beta. Then for this optical instrument called as for any optical instrument for that matter, not only simple microscope. For any optical instrument, we do not define linear magnification. We define a parameter called as angular magnification. So what is angular magnification? Angular magnification is defined as the angle subtended. So first listen, it is defined as the ratio of the angle subtended by the image at the eye to the angle subtended by the object at the eye. Basically, it is beta by alpha. Okay, so write down this parameter, which is called as angular magnification. What did I tell? The ratio of it is a ratio of angle subtended by the image at the eye to the angle subtended by the object at the eye. Angle subtended by the image at the eye to the angle subtended by the object at the eye. So angular magnification is also called as magnifying power. Both are same. So when they ask a question, they can say either find out the angular magnification or magnifying power. Image at the eye. Angle subtended by the object at the eye. Okay. Is it clear till this point? See, first concentrate on this. The remaining two optical instruments are the same procedure. So there the learning process will be faster. You have to concentrate. So when you talk about the image being formed, there are two locations which we choose by adjusting the object distance. One is you place the object between the focus and the optical center so that you have a virtual image on the same side, but that virtual image will be formed exactly at the least distance of distinction. But this time, but generally, what is least distance or distinction? It is the distance between the eye and the place where the object is kept. But here, the position is adjusted in such a way that, for example, your eye's least distance of distinction is 25 centimeter. You will adjust the object distance in such a way that the image distance with respect to the optical center is also 25 centimeter. Okay, it is adjusted. It is not going to happen naturally. It is adjusted so that you form the image at the least distance of distinction of what your eye has. Is that point clear? So again, it depends on how you do the experiment, with specs or without specs. You don't have sight, well and good. That depends. Right? Are you able to understand what I'm trying to say? So this is going to be the first scenario. For this first scenario, we are going to define or derive the angular magnification. Angular magnification is represented by capital M. So what is capital M? I gave you an equation. Angle subtended, so it is beta by alpha. But remember, with respect to optical instruments, all the angles considered are very, very, very small. So when the angles considered are going to be small, then what can be the approximation that can be done? You can write beta as tan beta and alpha as tan alpha. Am I clear with this point? Are you able to understand what I'm trying to say? You can write beta as tan beta and alpha as tan alpha. Okay. Now, draw this ray diagram. AW dash is the projection of point A onto the image. So actually what it is, the diagram is, actually diagram will be like this only. This is how diagrams written. Right. That object is state, it's formed, no doubt in that. But for us to bring this alpha and beta into the same context, what they are doing is they're projecting it here so that this distance, all this height is also the height of the object. This height will also be the height of the object as this. So that it forms a rectangle. Are you able to see this? Right? Then from the optical center, through the optical center, that is through the eye itself, through the eye, if you project it onto this point, what will this angle be? So just to bring alpha and beta into the same diagram, they write that. If this is confusing, you need not draw that actually. Are you guys able to understand or not? Beta what over here, the alpha there. You can draw beta alone, but not alpha. Are you guys able to understand this? If you're clear with this, I'll proceed. Shall I proceed?
Yes,
Hey,
sir.
don't nodding your head. Next class test will go. Clear? So what is tan alpha? Or sorry, what is tan beta by tan alpha? It is a magnifying power. But what is tan beta from the diagram? Solla? This beta. The period triangle. You need to take the triangle A dash. You need to take the triangle A dash B dash who subtend பண்றதா வந்து it is beta. புரியுதா? So A dash B dash O this is height of the image, which I'll call it as H dash by D. Am I right? So I can say this is H dash divided by capital D. புரியுதா? Similarly, what about tan alpha? It is H naught divided by capital D. Capital D and capital D will get cancelled. Why is it H naught by capital D? Because tan alpha is brought from the triangle A double dash B dash N. Correct? Purida Ilya. A double dash B dash cooler. This is there. This is H naught, but the distance is same D. This triangle. Okay, I'll shade it at least. Correct. Deed. This triangle I consider. This is what optical center and the B dash. Optical center and the B dash is capital D. Breathe. But here one point that you need to notice, H dash divided by H means what you are getting. You started with the concept of magnifying power, but what is that you landed up with? You landed up with linear magnification. So this derivation is actually not complete derivation. This tells us the fact that in the case of a simple microscope, right? I repeat, in the case of a simple microscope, angular magnification is exactly equal to the linear magnification in terms of magnitude. Means if you are able to find the linear magnification's value, that will be exactly equal to the angular magnification. Purida. Right? So make a note of this point first. So angular magnification is equal to, small m is generally used for linear magnification. Is it clear, guys? So in the case of a simple microscope, angular magnification is equal to linear magnification in terms of magnitude. They both are conceptually not the same, but the values are same. Right? So is this point clear? After this, things are simple. Now, what did I tell you? For every optical instrument, our job is only one thing: find what did I say? Repeat it, right? find angular magnification. Your job is to find angular magnification. But angular magnification, since it is equal to the linear magnification, now I'll start applying the formula 1 by V minus 1 by U is equal to 1 by F. Because it is a simple lens. But what is the value of B in this case? Where is the image formed? It is at the least distance of distinction. So 1 divided by D. D, how do you write it? Sign convention. Minus D minus 1 divided by U minus U is equal to 1 by focal length of a convex lens is positive or negative? Convex lens. Convex lens is positive. Okay. What is linear magnification with respect to a lens then? Sir, I'll make it simple. Okay, this might confuse you. Listen. Now, what I'll do is, I'll multiply with V on both the sides. When I multiply with V on both the sides, I'll get 1 minus V by U is equal to V divided by F. It's simple. 1 minus V by U is V divided by F. But what is V by U? What is V by U with respect to a lens? Linear magnification. So can I write 1 minus M is equal to V divided by F, which implies 1 minus V by F is small m. Now apply the values, which implies 1 minus, what is the value of V? Minus D divided by F is equal to M, which implies M is equal to 1 plus others. Now this linear magnification is telling us that the focal length is, so magnification is inversely proportional to focal length. Now we are able to relate it, that is why we need a short focal length or large focal length. Okay. So this is the magnifying power for whom? This is the magnifying power for a simple microscope when the image is formed at least distance of distinction, means when the image is formed at the near point. Purida. Those who are online are able to understand?
Yes, sir.
Done. So in a similar way, now we'll see what is the magnification when the image is formed at infinity. So case number 2. That is, so by the way, they have given it, see, the shorter the focal length of the convex lens, greater is its magnifying power. Inversely proportional. That's what you already put, right? Now, the second objective is I want the image to be formed at not the near point, I want it at the far point. So one thing is at the far point, any reason why we need to do it at the far point? A simple microscope at the far point. Because why do we need it to at the far point? Just to reduce the strain and extension. Okay, that is why the situation where the image is formed at the far point is also called as normal adjustment. In some of the questions they frame, right, they will not say that the image is formed at infinity. They will say the image is formed or the adjustment is, the normal adjustment is done so that the image is formed at some point. So normal adjustment in the word Pata, what should come to your mind? Means the image is formed at infinity. Why do we do normal adjustment? Only to make your eyes get less straight. Generally, when the image is formed at near point, your eyes will be slightly straight. Whereas at infinity, you will be more comfortable. Okay. See, this diagram is even more simple. In the previous diagram, where was the object kept? Between the focus point and the optical center. Whereas in this scenario, it is placed exactly at spin. So when you place it exactly at here, the image is formed at infinity. Is the point clear? So when it is formed, so here is your eye. So your eye is here. Right? And with respect to the eye, what is the angle subtended by the image? Since the image is enlarged, highly enlarged, right? What is the angle subtended by it? It will be beta. So if I take this right, I'll change the color bit. If I take this right angle triangle, what is tan beta? H by F. What is tan alpha? So I told you, wherever you need alpha, you need to look at the object without the help of an optical instrument. So what is tan alpha? H by D. So what will the magnifying power be? Here I didn't derive linear magnification. See, I'm still writing the formula for magnifying power. Magnifying power evo. So tan beta by tan alpha. So H by F divided by H by D. It will get cancelled. It will be D by F. So if you observe, how much is this less compared to the previous scenario? It is 1 less than 1 less by 1 unit. It is less by 1 unit compared to the previous scenario. Or if you just say 1, that's it. You don't call it as unit because magnifying power has no units. It's a ratio of the same physical quantity. Is it clear? Done. So two conclusions. Magnifying power when the image is formed at least distance of distinction is 1 plus D by F. When it is formed at the far point is capital D by F. Okay. So similar is going to be the case with respect to other optical instruments also. Whatever we did here, we are going to do the same thing. One is we make the image get formed at the value capital D, and the second is we will try to make it form at the infinity. Okay. So if you observe, this magnification is 1 less than the magnification when the image is formed at the near point, but viewing is more comfortable when the image is formed at the infinity. Okay. Next. So we'll do an example based on this. So read the question. There is a thin convex lens of focal length 5 centimeter. There is a thin convex lens of focal length 5 centimeter. Is used as a simple microscope by the person with a normal near point, that is 25 centimeter. What is the magnifying power of the microscope? So what is given? Focal length is 5 centimeter. D is equal to 25 centimeter. Magnifying power is asked. What is the value of magnifying power when it is formed at 1 plus D by F? Right. 1 plus D is minus 25 divided by 5. Correct? So what should be the answer? 1 minus 5 minus 2. Correct? But answer match was I did a mistake. Yeah. But why in other cases I told you, you need to apply the sign convention when you're sorry. You already use sign convention, and this is a particular scenario. When will you use sign convention? Again in the problems, only when it is a general scenario. For example, in the case of length formula, what do? You derive one length formula for 8 situations. So that is why you need to apply sign convention. But here, what did you do? You derived it for a particular situation. You already applied sign convention, you need not do it again. Okay, this point I wanted to get registered. Good. So 1 plus 5, which is going to be 6. So this is answer. Here. Am I clear? Next. Look at the 119th example. So a simple microscope is a combination of they have formed a simple microscope as a combination. This is a hypothetical situation. They wanted to frame a simple microscope which is a combination of 2 lenses in contact. So they brought 2 lenses in contact with each other so that the powers of the lenses are plus 15 diopter and plus 5 diopter. Plus power positive represents what? It's convex, right? Calculate the magnifying power of the microscope if the final image is formed at 25 centimeters from the eye. So the only thing that you need to know here is magnifying power, same formula. What is it? M is equal to 1 plus d by x. So 1 is 1 only, d is 25. But focal length is what you need to find by using the lens in contact formula. So what is it? 1 by f effective is equal to 1 by f1 plus 1 by f2. So 1 by f1 is how much? 15 plus 5. There is going to be 20. So 1 by f. So f will be equal to 1 by 20. So how much is it? 0.05. 0.05 meter or 5 centimeter. So this is 5 centimeter. Actually, you will get it as 0.05 meter. Right. So take it and substitute it here. The answer is the same as previous case. So both are same problems, except the fact that then they directly give you the focal length here. They ask you to find the focal length and then right. So clear. So make a note of this. Copy it. So that's it for today. You can log off right one. 20 diopter. 1 by 15 diopter is in terms of meter. Now, power formula I would have explained. Power is equal to 1 by f when f is expressed in terms of meter. Power is 100 by f when it is represented in centimeter. Correct? So if you write it in the reverse order, you will get it. Right? Right. So these are the 3 questions which are supposed to answer. Simple. That's it. Second brilliant. In terms of angle of deviation, minimum deviation, you explain money to I'm saying you have to explain that and then you have to do it. Minimum deviation could be deviation then. Okay, close your books. First question. I need the read See you close it. Those who are online start writing. Still. ஏன்னா எழுதுறப்ப எனக்கு ரைட்டிங் எழுதி ஸ்கிரீன் எழுதிட்டு எக்ஸ்பிளைன் சொல்லி நெக்ஸ்ட் டைம் வந்து பென்சில் வரணும். நீ என்ன சொல்றேன்னா become parallel to case இருக்கும் e will be equal to I. அதுக்கப்புறம் தான் இது ஆர் ஏன்னா இது டைரக்ட் எப்படி வந்து தெரியும். ஸோ டெல்டா இஸ் ஈக்குவல் டு கரெக்ட் தான். இப்போ நீங்கள் ஐ ப்ளஸ் அடுத்தது வந்து இது ஸோ இது வந்து ஓகே ஸ்பேஸ் பிரேக் ப்ளஸ் பண்ணி ரே டயக்ராம் வந்து ரே முக்கியம். Parallel to this. Okay. How did you understand first of all? உனக்கு ஃபர்ஸ்ட் டிரைவ் பண்றது கம்ஃபர்டபுளா இருக்கும். நெக்ஸ்ட் டைம் இது பண்ணிக்கோ and use pencil. Okay. ஹெல்ப் பண்ணாதா? பேசாதா? அப்ப டிஸ்டர்ப் பண்ணாது. This parallel to the base of this. That's right. The diagram for minimum deviation next time. I told her it's good. இது வந்து if you want to we'll understand that this is parallel to this. ஏன்னா நீ எக்ஸாக்டா லைனுக்கு தகுந்த மாதிரி ஒர்க் இருக்கு. இது என்ன ஆகுதுன்னா ஆறு சடனா ஆர் டேஷ் எனக்கு தெரியலன்னு வச்சுக்கோ. ஐ மீன் ஸ்ட்ரைக் அதனால always draw it at this way. Okay, don't draw it parallel to this. But delta I plus I dash. இது போதும். Then why did you rewrite it again like this? In the diagram. Okay. The paper expert. And இது பார்த்தா எனக்கு என்ன தெரியுதுன்னா இதுவும் இது பேரலா இருக்கிற மாதிரி இருக்கு. கொஞ்சம் டிஃபரெண்ட் ஆகும். ஓகே. எது எடுத்து எது சீன்னு எனக்கு தெரியல. and இது பார்த்தா நான் டக்கு 90 டிகிரி மாதிரி தெரியுது. CA 180 minus n போட்டுருக்கேன். புரியுதா? சின்ன சின்ன விஷயம். ஒரு டேட் டயக்ராம் வரையணும். Time of the paper. Higher writing with orange blue colorful. I எத்தனை கலர் நான் எழுதுனது எப்படி தெரியும்? நெக்ஸ்ட் டைம் ப்ளூல பிளாக். ஓகே. The time of them. Those are online submitted in the app. Okay. Yeah. சரியா இது படிச்சாலும் உனக்கு பாதி அப்புறம் நெக்ஸ்ட் டெஸ்ட் நல்லா பண்ணு. சரியா தெரியுதுங்க. ரெடியா இருக்கியா? 7.4 படிச்சியா? 7.4 படிச்சியா?